that AB is greater than DE? Here AB is greater than DE. So we can take a point P on AB such that this PB is equals to DE. Now let us consider the triangle PBC and the triangle DEF. So if you observe that in this triangle PBC and DEF, PB is equals to DE by the construction, and angle B is equals to angle E, which is already given, and the BC is equals to EF, which is also already given. So from this we can conclude that the triangle PBC is congruent to the triangle DEF by the SAS congruence. Here, since the triangles are congruent, then I can see that their corresponding parts will be equal. So the angle PCB is equals to angle DFE. But we are given that the angle ACB is equals to angle DFE. So what we can do? We can substitute the angle ACB is equals to angle DFE in the equation which is angle PCB is equals to angle DFE, where I'm going to get angle ACB is equals to angle PCB. Now, is this possible? Yes, this is possible only if the P coincides with the A. Or I can say if BA is equals to ED. So I can say that the triangle ABC is congruent to the triangle DEF by SAS criteria. Now let's see the third case, which is if AB is lesser than DE. See here, similarly like case 2, we can choose a point M on DE such that ME will be equals to AB, and by repeating the same arguments which we did in the case 2, we can conclude that AB is equals to DE, and so I can say that the triangle ABC is congruent to the triangle DEF, and this is about the third case for this theorem. So in the next class, let's see few more criteria for this congruence of a triangles.